Hi everybody, this is Dr. Nageswara, Assistant Professor of Physics, SRR Severe Government Degree College, Autonomous Vijayawada. In the previous presentation, we will discuss about different rockets sent by the ISRO. Now in this presentation, we will discuss about different satellites which are sent by the throughout the world, different organizations. Actually, what is a satellite? Satellite is a body which is revolve around any planet. That may be Earth, that may be Jupiter, that may be Mars, that may be Saturn, whatever it is. When a body which is revolve around the planet is called satellite. There is actually two types of satellites we have in this case. One is called natural satellite, second one is called artificial satellite. So what is natural satellite and what is artificial satellite? Natural satellite is nothing but which occurs naturally. There is no interference of the people. For example, we know the moon which revolve around the earth. That moon is not prepared by human people. So moon is the natural satellite. Similarly, remaining planets also having different satellites. This is an artificial satellite. Here artificial satellite is nothing but which is prepared by the people and it is sent by the rockets and which also revolve around the different planets. Actually, most of these satellites are prepared by the human people to revolve around the earth, to study the earth. And of course, there is what is natural satellite is nothing but it is an astronomical body. Astronomical body is nothing but it is happening naturally. So I know what we discussed about, we have number of different planets we have in our solar system. Actually in previous days we called that there is 9 planets we have. But thereafter the Pluto, actually there is very small astronomical body that has not having properties of the planet. So now it is not considering as the planet, now we have only 8 planets we have. Out of these, the first two, that is Mercury and Venus, they have no satellites. Those size is very small and nearer to the sun. Maybe different conditions, there is no satellites available to these two planets. We know Earth has only one satellite, that is Moon, as shown in this diagram. And Mars having 2 satellites we have. Jupiter having 95 satellites we have. You see here, that is Jupiter, that is one of the biggest planet in the solar system. It has 95 planets, it is nothing but just like 95 moons. We know in the full moon day, we are observing that there is more light on the surface of the earth for a single moon, for a single satellite. But here when we observe, there is 95 satellites we have for this case of Jupiter. In this case, 95 satellites is nothing but in the night time also, there is more light we may observe. But there is no intensity because there is only reflected light. Not only that, and thereafter Saturn having 146 satellites. In other words, what we say that 146 moons are there. So just like that, very good lighting we have. Generally, what we said is nothing but there is a number of tube lights when we are arranged in a single room. How much intensity is there, same light we can observe on the surface of the Saturn because of the 146 satellites we have in that case. And there are Uranus having 28 satellites and Neptune having 16 satellites. Of course, the largest is a Triton on the Neptune, and Pluto is a white dwarf planet. It also has 5 moons. There is 5 satellites we have. This is about the brief history of the natural satellites which occur on the solar planet system. Now what about the artificial satellites? Artificial satellite is nothing but which is made by the people, which is sent through the different orbits of the earth by using the rockets. We know rockets already we discussed in the previous presentation about that. That may be PSLV, ASLV, GSLV and different, these are all rockets prepared by our Indian organization. Of course, different countries, just America, Germany, China, just like those countries also prepared their own rockets to send these satellites into the different orbits. Now we will discuss about these different types of satellites we have in this case. There are currently 3,000 artificial satellites are working in the space. Of course, actually there is more than 5,000 satellites are sent by the human people. Those remaining satellites are not working now because the lifespan is very small. For example, when we send INSAT series of satellites, whose lifespan is 5 years to 10 years only. After 10 years, this lifespan is completed, the power is going off. When there is no power, that satellite did not work. So that is in the dead position. So similarly, there is thousands of satellites are not working now, but still 3,000 satellites are in active position surrounding the Earth in different orbits. Actually, these satellites depending on the different categories. Though some of the depending on the size, depending on the altitude, and depending on the design. So designing is also depending on the what is the purpose of sending these satellites. Maybe for communication purpose, maybe for taking photographs, maybe for taking weather forecast. So depending on these purpose, the satellites can be classified into different cases. Of course, satellites are orbit at different heights, different speeds, and also along different path also. You see here. In case of generally we may say that there is two orbits, we may say that one is polar orbit and the second one is geostationary orbit. What is polar orbit and what is geostationary orbit? Actually, polar orbit is nearer to the Earth. In that orbit, that is artificial satellites is revolve from north side to south side. During this rotation of these satellite around the Earth, we can take photographs of the Earth surface. We can study the minerals which are available in the Earth. So this is the importance of these satellites. Those are called polar satellites. So polar satellites is nothing but whose which is revolve around the Earth from North Pole to South Pole. And the second one is called geostationary. That is we say in this case second case. So geostationary satellites is nothing but which revolve around the Earth from west to east at a distance of 36,000 kilometers, right? It is nothing but from the Earth's surface, the height of this geostationary satellite is around 36,000 kilometers. So what is the place where when we kept this 36,000 kilometer height, what happens? Why it is called geostationary satellite, we will discuss now later. Actually, this is the, when we observe, this is one of the artificial satellite. So what is the history behind the satellites? Firstly, the first artificial satellite which was sent by the Soviet Union, that is called USSR. Now it is called simply Russia. After Gorbachev reform, so that USSR is divided into the different countries. One of that countries now it is called Russia. That was sent in 1957 October 4th. That is Sputnik 1. That is the first artificial satellite sent by the human being. And the second rocket which is sent by the America in 1958 by using their center that is called NASA. Now after 1958 we have taken some time because at that time our country India have a number of problems because recently we got independence and there is some financial problems we have. There is no agriculture products is sufficient. There is no irrigation projects we have. There is no industries we have. There is so many problems we are facing at that time. Even though at that time the Prime Minister of India, Jawaharlal Nehru, has decided to take part in the research on space also. So at that time they decided to improve the space preparation and to make rockets and to make artificial satellites also. On that condition in 1975, The first Indian satellite was sent by the support of the Russia by using a Russian rocket that is called Aryabhatta. We know Aryabhatta is the one of the greatest scientists of India in ancient days. So on his name, we sent the first rocket, that is Indian artificial satellite, that is Aryabhatta. Of course, later we also sent a number of satellites into the space. Now we will discuss later. So these satellites vary in size, basically depending on the requirement. So depending on the financial sources, depending on the purpose, these satellites are different sizes we have. One of some of the satellites are whose size is only 10 centimeter length. That is also called micro satellites. So it has given very small information to us. And later we have prepared, that is communication satellites, whose length is around 7 meters. Of course, 7 meters is only the key part of the satellite only. But how it will work? The power is required. But we cannot give the power from the earth for continuously 10 to 15 years. So that we want to make some solar panels. So that those are the solar panels whose length is nearly 50 meter to work that 7 meter length of communication satellites. So the length of the communication satellite is only actually 7 meter, but by using these solar panels, whose length is 50 meter. Now it is not stopped there. So this is you see in this diagram, that is actually International Space Station. So where the scientists can stay for days or months or years for research purpose. So you see in this case International Space Station, whose length is a size of 5-bedroom house. So there is a what is the area, plinth area of the 5-bedroom house when we observe, that is the size of the International Space Station. But what is the actual length? Because we know we require power supply by using the solar panels. After adding these solar panels, whose size is large as a rugby field. So that is the, we is here, one observe these satellites, the more space is required to prepare the solar panels. And depending on these altitude of the satellites, because all these satellites are not in the same position or same orbit. If all the satellites are placed in the same orbit, maybe they will be collapsed. And the properties or the usage of satellite is also depending on that distance. So depending on these distance, these orbits are 3 types. Of course, previously we discussed that there is polar orbit and geostationary orbit. In medium, one more there, that is called medium level. So first one is lower Earth orbit. The lower Earth orbit is near to the Earth, whose size is 200 kilometer to 2000 kilometer. Actually, polar satellites, what we discussed. Polar satellites whose height of the orbit is nearly 200 kilometer to 400 kilometer, or around 2000 kilometer only. So due to the distance is lesser than the remaining satellites, the photographs taken by these satellites is very clear. Now, okay, nowadays we are taking Google Maps. The Google Maps who's prepared by using these polar satellites. Nowadays we can see even even a rat which is moving on the Earth also, we can clearly see by using these polar satellites, whose radius is around the 200 kilometer to 2000 kilometer only. Of course, these ISS, already previously we discussed that, International Space Station, which is also situated at the distance of 400 kilometer. Of course, whose speed is 28,000 km per hour, and it takes 92 minutes per one revolution to surround the Earth. Is nothing but by using within the 90 minutes, it can take one complete round, and they will take photographs every 90 minutes once again. And the second one is medium Earth orbit, whose around is 20,000 kilometer height altitude. Actually, there is a very few applications or very few users we have whose satellite situated in this medium Earth orbit. And very important is that is a geostationary orbit. It is at 36,000 kilometer above the Earth surface. So what is its importance? When these satellites situated at the 36,000 kilometers height, when it is revolving around the Earth, the time taken for one complete revolution is 24 hours. We know the rotating time of Earth is also, that is rotational time of our Earth is also 24 hours. And at the same time, these satellite is also taken 24 hours for complete one revolution. So it means that what is happen when we observe one rocket is situated at the top of our head at a 36,000 kilometer height. When we observe that, always it is situated our head only. It's nothing but it looks like stationary. So this is called a geostationary satellite. Is nothing but with respect to the Earth, it is stationary. So that is called geostationary satellite. So these geostationary satellites will be used mainly for the purpose of communication system. Maybe telephone channels, televisions and telephones, etc. TV that is maybe used by using these geostationary artificial satellites. Depending on the usage, depending on the applications, these satellites can be divided into different types. Maybe navigation satellites, communication satellites, earth satellites, etc. So one is navigation satellites. We know all of us we are depending on the GPS, global positioning system. When we want to go unknown place, nowadays there is no problem. Previously 20 years back when we want to go one place, there is a number of obstacles. We want to search the address, door number is required. We want to ask some of the people, where is this street, where is this house, what is the door number, where it is the door number. Then only we reach that place. But nowadays there is no requirement. Simply by using this GPS, one location is sent by our relatives, our friends. Then directly when we are starting on our cell phone by using GPS, we can easily reach that position without depending on other people. So that is beauty of these navigation satellites. These navigation satellites, one geo satellite is not sufficient. There is working more, minimum of 24 satellites are working at a time. Of course, maximum of 32 also. So these satellites are situated at the height of 20,000 kilometers height. The combination of these satellites, they will signal to us to send the location of that position where we want to go. So that is important of the navigational satellites. Second one is the communication satellites. Actually, these are geostationary satellites, where the geostationary orbit, the satellites which we are sending, where it is situated, those are used to get the television channels, phone or internet connections we will use. What about India? Now India also we send a number of geostationary satellites into the space in sat series mainly. In sat series, INSAT 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D, 3A, 3B, 3C. These satellites are geostationary satellites which are very helpful to us to get these communication system. Actually, lifetime is also, for example, INSAT 2A, what we said, the lifetime is only 10 years, but they worked more than 15 years. Because the greatness of our scientists, the power is very efficiently sent to the mission, it worked more than what we expected. And weather satellites. In these weather satellites, you know, nowadays we want to take any information of the weather. Next 24 hours there is rainfall. The temperature is very high. The winds are coming. The cyclone will be arised in the within 24 hours. There is maybe a tsunami. So all these information can be collected by using these weather satellites. Of course, to get this weather, we may use these geostationary satellites as well as polar satellites also. And the next one is Earth observation satellites. It means that to take in photographs. To take photographs, these Earth observation satellites will be used. And the last one is astronomical satellites. It is nothing but to study the Earth. Not only that, to study the space, to study the different planets, to study the different solar systems, to study the Milky Way galaxy. So, these satellites, astronomical satellites will be used to study about all these applications. The orbit of these astronomical satellites is about 2.5 lakh kilometer to 8.32 kilometers height. This is nothing but very, very far to us. Very, very far to us. And International Space Station is this situated around 400 kilometer height from our Earth's surface, where the scientists may stay. They will study about the what is happening surrounding us, etc. Of course, whose speed is 28,000 kilometers per hour. Already we discussed in the previous slide. Now, what about Indian satellites? We know the first satellite, which is 1975 in April 19th, that is called Aryabhatta. Not we stopped there. Thereafter, we developed our own rockets, we developed our own satellites also. By own rockets, we know by using their scientists, that is by using sounding rocket, we started here. Thereafter, SLV, ASLV, PSLV, GSLV, so many rockets we developed to send the artificial satellites into the space. Of course, the first of the satellites, Aryabhatta, Rohini, etc., they and insert some of the series of satellites sent by the other countries. We are depending on other countries. But now, after successful of the PSLV and GSLV, now our own satellites we are sending into the space by using own rockets. Of course, even foreigner satellites also we are sending from our rockets. There is some of them satellites are insert series of satellites. IRS, Indian Remote Sensing Satellites. These are polar satellites. EduSat, GSat, Chandrayaan, thereafter Mangalyaan. So many satellites we are sending from our Indian origin. Mainly from our Andhra Pradesh, there is a Sriharikota, that is a space launching station we have, from where we are sending a number of satellites into the space. So, this is about the greatness of the scientists. Now, in the next presentation, we will discuss about what is the successful of the Indian satellites. So, thank you very much for watching this channel. Thank you.